given a 4-function calculator for this test.
You're going to give it to
I will give it to you. So I would suggest on tonight's homework, you actually use the 4-function calculator, which means just the home screen. You shouldn't use the graphing part. Here's why. What we're learning today is a test to determine if a function is increasing or decreasing. Obviously, when you look at a graph, don't you know where it should be increasing or decreasing? We did that all last year, okay? So this time, you actually have to use what's called the first derivative test, which we're going to talk about today. So I will let you have a 4-function calculator, which I will supply for you, but do not look at the graph today. Try your very hardest to not look at the graph on tonight's homework. So let's get started, shall we? Ready? Yay! So, so here's a graph.
Okay. Whoa.
I know, just go with it, all right? So if you remember, again, you start on the left side of the picture and you work your way to the right. You always start on the left, just like you read a book, left to right. Your graph right now is doing what as I move my pencil? Decreasing. Even though the arrow is pointing up, the function itself is decreasing. This point right here where it levels off is constant. This point right here, now my pen is increasing, okay? So obviously when you look at your graphing calculator, you can tell where the function is increasing and decreasing. But again, back in the day, they didn't have cool graphing calculators. So they had to do a test to see where the function was increasing or decreasing. So testing for increasing, decreasing function. And I'm going to give you the steps, and then we're going to do 4 examples, and that's it for today. Testing for increasing. All right, so step number 1, obviously, we're going to find a derivative. Find a derivative. Why is that? Well, remember, derivative is the slope. If I were to take the slope right here at this point, if I were to draw a tangent line at that point, what would be my slope? Would it be positive or negative? Negative. Even here, still negative, still negative. But then when it's increasing, what kind of slope do I have? Positive. So when I find a derivative, I can tell where it's going to be increasing or decreasing based off of if it's going to be positive or negative. So step number 1, find a derivative. Step number 2, locate what are called critical numbers. And you've done this part before when we were determining where the graph is horizontal, where there would be a horizontal tangent line. But what you actually do is you set your derivative, your f prime of x, equal to 0. Or if it's a fraction, wherever the denominator is undefined also. Undefined. Okay, those are called critical numbers. That's the number, that's the point where it'll change from increasing to decreasing or decreasing to increasing, or it might not change at all. Step number 3, you are going to test numbers in a testing interval, which I'll explain in a minute. Hey, Miss Sutton. And testing, oh my gosh. Thank you. It's all good, just leave it. just leave it. Let him be a part of the fun. That was good. Oh, it smells so good now. It's going to be much longer than 20 minutes now.
So it's a male.
Hey, thanks. Test numbers in the testing intervals by plugging into the derivative, okay? So I'm going to show you what I mean by this. And then step number 4, this is what we just talked about, okay? If your derivative, if those numbers that you plug into the derivative, if those numbers happen to be bigger than 0, meaning if those numbers are positive, then your function is what? Your function is increasing, okay? So then we know, then it's increasing, okay? If you plug those numbers into the derivative and you get negative values, which means numbers that are less than 0, then obviously it's what? Decreasing. Makes sense, okay? If you happen to plug your numbers in and you get them equal to 0, you actually probably did a mistake there, just so you know, this first time around. I'm going to write then it's constant, but probably what you did was you probably plugged in the critical number. So you might want to like just kind of put a little hint there. You plugged in a critical number, which you don't want to do that. Not in this chapter, not right now, okay? So take a derivative, set it equal to 0, do this testing interval thing, and if it's positive, it's increasing. If it's negative, it's decreasing. We're gonna do 4 examples, and we're gonna be done. Now, you're gonna try to probably pick up a pattern, because that's what you are. You're pattern people. You love patterns. But don't think there's always a pattern. I'm gonna switch it on you in a minute. All right, so find the increasing, decreasing intervals. That's what the directions will be for all of these. Find the increasing, decreasing. Example 1. F of x equals x to the third minus 3/2 x squared. And again, I want you to try to do this all without a calculator. So, number 1, take a derivative. Let's see if you remember. Jack, take a derivative.
Hold on.
Ugh, never mind. Jed.
Minus 3x.
Good job, Jed. Jack Jed.
Dang it, Jack.
All right, once you take the derivative, set it equal to 0, okay? Which you've done before when we were doing those tangent lines. You're going to, so I guess this is step 2, factor out from here. You're going to factor out a 3x. You'd be left with x minus 1 equal to 0. From here, determine what your critical numbers are.
0 and 1.
Correct. 0 from the 3x equal to 0. 1 from this one. Okay, so these are my critical numbers. Very important that you find those. Okay, once you do that, you're gonna do something that you may or may not remember from last year, which I called a sign test. And I'm gonna do the same thing actually this year. So you make this, and I'm gonna put f prime of x for a reason. You make this number line. This is actually the x-axis. On the x-axis, in order, you put your critical numbers. So you put 0 and 1, okay? And you are going to test, this is an interval, this is an interval, and this is an interval. This is the interval from negative infinity to 0. Would you agree? This would be from 0 to 1. This would be from 1 to infinity. You're going to test into the derivative, and I like to do what's called a sign test. That's what I like to do. You don't really have to get the number is what I mean. So here's what I'm talking about. Pick a number that comes in this interval. What would be a number? Negative 1. If you pick negative 1 and you plugged it up in here into the derivative, wouldn't this still be negative, right? 3 times negative 1 is negative. Don't even worry about the number. Wouldn't this still be negative? Negative 1 minus 1 is still negative. But what is a negative times a negative? Oh, so in this interval, no matter what number you picked, you would get a positive answer from the derivative, which means the derivative in this interval is positive, which means the function is what?
Increasing.
That's what it is. It is increasing in this interval. Okay? Then we plug a number in here. So 1/2. But again, I don't care about the number. I just care about the sign. 3 times 0.5 is still positive. But 0.5 minus 1 is negative. A positive times a negative is negative. So I'm decreasing. And then I pick a number 2. That would make this positive. 2 minus 1 would be positive. Positive times positive is positive. So I must be increasing. That's it. And then you write your answer in an interval notation. So you would say, okay, Mrs. Seta, I'm increasing. You can write I don't care if I write just INCR. I'm increasing from negative infinity to 0, but I'm also increasing where? 1 to infinity. And by the way, these will never be bracketed. We're just talking about an interval. So we don't need to worry about brackets and things like that. I am decreasing though from where to where?
Zero.
And that's your answer. Done. That's how you find out if a function is increasing or decreasing.
So you wouldn't put a U between?
No, we're not, you don't need to.
Okay.
You can, some books do, so you don't need to. Let me just give you an idea, by the way. Had you graphed this in your calculator, hold on one second. It's going to look like this. It actually is going to be a disco, but you'll see, so from negative infinity to 0, here's 0, isn't my function, my pen is going up? Then from 0 to 1, it's going down. And then from 1 to infinity, it goes up. So obviously you could read, I know you all know how to read a graph, but you got to do this first derivative test, okay? Jack, question.
I like,
Andy, what's my derivative? I'm calling on people because it's been a while.
3x squared minus 12.
Beautiful. Set it equal to 0. We can factor out a 3. We're left with x squared minus 4. But what does that factor into?
X minus 2.
Okay. So this 3, although may seem not important, it's not a critical number. It's not. But it is going to help us when we do our sign test. So just leave it out there because sometimes you might factor out a negative 3. That would be a part of your sign test. But what are my critical numbers then at? 2 and negative 2. So on my axis, I'm going to draw negative 2 and 2. And then I will perform the sign test. And I like to perform it right in here, right where it's factored. And I just start picking numbers. So I pick a number that's less than negative 2. I mean, you could pick like negative 10. Positive, this would be negative, this would be negative. What's a negative times a negative? So it is increasing in this section. Negative 2 to 2, I don't know, pick 0. What would my sign be of this function? Positive, negative, which is negative. So it's decreasing. Pick a number after 2. What do you think is going to happen? Positive. So, increasing from where to where?
Negative to negative 2.
And then where else? And where is it decreasing? Now, does anybody think here that, Mrs. Seta, are you telling me that it's always going to be increasing, decreasing, increasing, or decreasing, increasing, and decrease? Can you think of a time where it's not going to be? It's going to happen. This one, just so you know, if you don't remember, this again is one of those, Miss Davis calls it a disco graph, but it goes up until negative 2. And then negative 2, it goes through 0, but right here at 2, well, that's a little, I should make it wider, but 2, it turns and goes back up. And that's what that graph looks like. All right. Is this making sense to you? I know it's been a while. Let me do our third example. We only got 2 more left. This one's important because, well, you haven't done this derivative in a while. F of x equals, x squared minus 4 to the 2/3. You don't have to do the u stuff anymore because I think you should probably know how to do it without the u's necessarily. Let's see if you can remember. Anybody want to tell me what the derivative of this is? Do you remember? 2/3 x squared minus 4 to the negative 1/3. Remember, you have to take the derivative of what's inside. That was the u. Okay, you got to attach it. So, and then this is why Mrs. Seta was so much of a pain that I made you rewrite this because you have to find the critical numbers. So let's talk about this real quick. What's 2/3 x times 2x? What is that? 4x over 3. Okay, so I have this fraction. I have 4x. I have 3 on the bottom. Where does this go? On the bottom. And becomes positive. If I set this equal to 0, and I want you to write this down, because we got to find critical numbers. Your critical numbers, by definition, are numbers that make the numerator 0, which almost everything we do is usually in a numerator, but also make the denominator undefined, or 0. So critical numbers are any number that makes the numerator equal to 0 or the denominator undefined. So if you get one like this, which you will, where it looks like a fraction, your critical number would be, just look at the top right here. What would it be for this one? 0. Okay, so x equals 0. But then where does, really, it's just this right here. Where does this right here become 0? Because 0 times 3. 2 and negative 2. Okay, so that's what your critical numbers are. That's where those points are going to turn from increasing to decreasing, whatnot. All right, so this would actually be 2. This would be 3, step 3. So now on my x-axis, this up a little bit more, I actually have -2, 0, 2. By the way, I know this seems silly, but please make sure you put these in order. I have so many students put like 2 here, 0 here, and negative, like you switch them. Don't do that. Not you. Never. Okay, so now I actually have 1, 2, 3, 4 zones to test. There's going to be 4 here. So let's pick a number that comes before -2, so -3. My top would be negative, agreed? If -3. My bottom, -3 squared is what?
9.
And 9 minus 4 is a positive number, agreed? So negative divided by positive is negative, which means I'm decreasing. -2 to 0, let's plug in, -1. That would be -1.
Would it be the same thing?
Well, here, let's watch what happens. What's -1 squared?
1.
1, but 1 minus 4 is negative. So it's negative over a negative, which is positive. So that's increasing. Yes, aha. Plug in 1 would be positive over negative, which is negative. And then plug in a larger number than 2, you get positive over positive, which is positive. So, answer the question. I'm increasing from where to where?
Increasing from -2 to 0,
Thank you, Kyler.
and from 2 to
Thank you. And then I'm decreasing from -infinity to -2 and 0 to 2. Okay? And anyway, this one, just so you see what this looks like, again, you could put these in your graphing calculator, but this one actually, it decreases to -2. It does this weird increase up until 0, comes back down, decreasing, and then goes back up. It's this weird like W shape looking thing. All right. All right. One more, I'm done. This one is different because, well, it goes against all the other ones that we've done. Oh, it's increasing, decreasing. It's always going to be in that pattern. It's not. X cubed minus 3x squared plus 3x. Start it off, take a derivative. What's our derivative? What's my derivative, TA?
3x squared
Mhm.
minus 6x plus 2.
Excellent. Set equals 0. This is a trinomial. You can still factor out a 3. You get x squared minus 2x plus 1. Two numbers that multiply to 1, but add to a -2. -1, -1. Now, you can write it like this. Some students in their class want to write it as something squared. It doesn't matter. I'm just going to leave it like this. It really doesn't matter. All right, step number 3. Write your critical numbers on here. Well, really, you only have how many critical numbers? Really 1, right? 3 is not a critical number. Again, it's not 3x. It's just 1 from both of these. So you just have 1 critical. You only have 2 zones to test, really. Numbers that come before 1, numbers that come after 1. So pick a number that comes before 1. I pick 0. 0 and 0 would be a negative times a negative. Agreed? Which is what? Positive, increasing. Pick a number after 1. Watch what happens. This would be what? Like 2. 2 would make this what? Positive, positive again. What? So what's happening? How do I write this? Well, you would say you are increasing the entire time, which means from where to where? I'm increasing the entire time. And that makes sense. Again, this is Miss Davis's famous disco graph here.
Past it forward.
It goes like this, and then it just kind of does this little, it's called a point of inflection, which we'll actually find out about. So it increases, kind of dips a little and increases still. It increases the entire time.
Those things, all we know is-
Okay? Yes. But that's it. Oh, I'm sorry. I want to do question number 10 for you, which is your first homework problem, which for whatever reason, every year they don't know how to do this one.
Yeah, what does that mean? We won't figure it out.
Here's what they always do. To Seta, I took the derivative. What's the derivative of this? Can you set -3 equal to 0?
No.
No. But your derivative the entire time is negative. What does that mean? I am decreasing the entire time. And that makes sense if you actually think of this graph right here. This is a line. Is this not a line with a negative slope?
Yeah.
Oh, isn't it decreasing the entire time? So there's your answer. There you go. I just did number 10.